Okay, and on to composition of functions. Composition of functions refers to when you have two known functions and you then essentially insert one function into the other, or making one function sort of the independent variable, if you will, in the other function. Now, doing the algebra is typically a little bit easier for most people, but then finding the domain is where we get a little stuck. And so we're going to focus on doing that in the problem below. One thing I would like you to keep in mind throughout all this is, in general, if you do the composition in one order and then do it in the other order, they're not equal. There may be some cases where it works out, but in general it is not. And that is illustrated in this example down here. So let's just go ahead and dive in. So we're supposed to find the domain for both orders of the composition and then find the expressions for both, assuming that we're inside the domain. First thing I would like to do is identify the domains for both of these. So I'm going to use D, and then I'm just going to use a bracket F as shorthand to denote the domain. So the domain here, square root function, well, we know that underneath the square root we have to have numbers greater than 0, and we also, since this is in the denominator, we can't divide by 0, so actually our domain is restricted to this, and so solving we get x is greater than 9, and so this would be on the open interval 9 to infinity. Okay, and then the domain for g of x is, this is a polynomial, second degree polynomial, and so the domain of g is the same as the domain for any polynomial, which is all real numbers, so minus infinity to infinity. Okay, so now I found the domain of both inside functions, but now I need to find the domain of the composition, and in order to do that, you actually need to do a little bit of the algebra first. So let's go ahead and start with f of g, and that's how you say, it's not fog, it's f of g, and a lot of people mistake this as the multiplication sign. It is not the multiplication sign. And so this is the same as saying f of g of x. Okay, so this says I take my g of x and insert it into f wherever I have an x occurring. So this is equal to 3 over the square root of, now I have x, so I'm going to replace that with x squared minus 9. I'm going to put that in parentheses, extend my square root, and then minus 9. This is plus 9. Okay, and so I can do a little simplification here. 3 over the square root of, and then if I do the simplification, drop the parentheses, this simplifies the square root of x squared. Okay, and this, a lot of people will just say this is 3 over x. It's actually, if we square root a square, we actually end up with an absolute value. Okay, and then so the domain of this is, and I'll do this in green, domain is really, we have to have, we can have everything except x can't equal 0, so I'm just going to make that little side note. And so the domain here, domain of f of g is equal to, okay, I have to do the domain of the inside function, that's g, so it's going to be negative infinity to infinity, okay, and I have to intersect that with whatever the domain of the composition is. So I said the domain is all real numbers except 0, so this is, I'm going to use double bar r to mean all real numbers, same as this, except the 0. Okay, and this intersection, so this is saying I have all real numbers, but I also have to have all real numbers except 0. So what values do they have in common? Well, this is actually all real numbers except 0. Okay, so I have to remove any values that are I have to remove values from here, and I'd also have to remove it from here. So look at the overlap. Intersection refers to overlap. Okay. Now, doing the other composition, I'll do that in black. So I'm going to do G of F. I'll make that circle a little bit bigger, of X. And so this is saying into the G function, I insert F of X. Okay, so let's see, G is X squared minus, or X squared plus 9. So let's see, and now I replace every X in here with this output. So I'd have in parentheses 3 over the square root of X minus 9 squared plus 9. Okay, I can do this, but keep in mind I need to find the domain. Well, the domain here is actually going to be just the same here. So what values would make this expression this expression undefined? And really, it's just saying, well, I can't have these values, but that's already the domain of f. So I'm just going to say here, make a little note, domain. I also have, to make this whole thing defined, I need to have x minus 9 be greater than 0. So I get a positive number that is not 0 underneath the square root. And so then I can, with that note in mind, I can continue to simplify here. So I'll get 9 over x minus 9 plus 9. Okay, and I need a little bit more room. So continuing the simplification here, I can find a common denominator, and I'll get 9 plus, and then let's see, the numerator will be 9 parentheses x minus 9, all divided by x minus 9. And so this simplifies to 9x minus 72 all over x minus 9. Okay. So I found the formula, and I just need to state the domain. Okay, so it was the domain of the inside function, which was f of x. So the domain of this entire thing was, I'm just going to say 9 to infinity. Okay, intersect with. So look for the common values with this, and, well, I also have that, which was also 9 to infinity. Same interval, so the domain is just 9 to infinity. Okay, so that's how you do compositions in short, but I also want to illustrate that f of g of x, or f of g of x was this, and g of f of x was this. So in general, again, the two orders are not equal. Okay, so that's a quick demonstration on composition of functions.